Okay, so let's revisit this. We've already investigated all these graphs and determined which graphs are functions and which ones are not. They're just relations. But what about domain and range? Now again, domain, these are basically my x inputs and range are my y outputs. But they are the inputs that actually create an output or vice versa. They're outputs that were created by some thing. So when we look at this graph, there's a lot of x values, right? I mean, there's an infinite number of x values going positively and an infinite number of inputs going negatively. But when I look at the domain here, capital D, the only values of x that seem to be producing outputs are -4, right? -2, -1, 0, and 1, and it looks like 2 and 4. And this is discrete, right? Because we're not talking about everybody from -4 to 4, right? We're distinctly talking about those 1, 2, 3, 4, 5, 6, 7. Those 7 values of x are producing outputs. So we have a discrete function, or actually a discrete relation. So the domain is going to be discrete. What about the range? Well, the same action, right? For these values of x, what values of y got outputted? So it looks like -4 is an output value, -3, -1, +1, 2, and 3. All right, so that would basically be our range for that data set that's shown. Again, we're discrete because we're not talking about everybody between -4 and 3. These specific 6 y values are the only y values that were created by all those x's. Same thing over here, the domain. If we take a look at it, includes -4. It looks like -2. It looks like 0, 2, 3, 4. Right? So at all those x values, there seems to be a point that's generated. There's a y value that was made. In terms of the range, at its lowest, it looks like we're at -1, and then it looks like we have 2, and then 3, and then 4. So for those inputs, these are the only 4 outputs that come out from regard to that. And so again, we have a discrete relations or functions, so I would expect my domain and ranges to be basically discrete. On the other hand, what you have in the rest of this page is we do not have a discrete function, right? What we do have is pretty much a continuous function. And so when I look at this, right, starting at -6, and how about we include it, and all the way to 10, and it's also included because of those dots, for all those x values, right, every single x value, the hard ones, the easy ones, the integers, the decimals, the irrational ones, whatever you want, every single x value has a y value associated with it, right? That's why we have this nice looking little curvy graph. So the domain in this case is going to be an interval, and it starts at -6, ends at 10, and then both endpoints are actually included. So this would be an interval from -6 to 10, including those endpoints. So it's pretty much, again, you can kind of see what part of the x-axis is shaded, if you would, by that. In terms of the range, same deal, right? So along the y-axis, it does look like -2, and then it looks like it's topping out at 6, and then we have all the y values all the way between those two values. So at the lowest, we're at -2. At its highest, we're at +6. And then we include those endpoints. So that's why we're using brackets, -2 to 6, and we have interval notation. In the next graph, what we have, I want you guys to get used to my ability to write tests. If I want the graph to end, you're going to see nice little points. But if you don't see those nice little points, your assumption is that there are arrows there, that this is going on for forever. All right, so make sure you read that. And again, down here for letter F, I see nice little points, dots. So this is basically stopping at a certain thing, as opposed to over here, I don't see dots. So that means these are going off forever and ever and ever in both directions. So what about the domain then? Well, it looks like for this function, since it increases forever this way, decreases forever that way, right, every x is going to be covered. So we have a very strong domain from negative infinity to infinity. However, the range, right, there's a gap, right? There's no y values between -2 and 2. So considering the first one, starting here and going down, and starting here and going up, right, we actually have two intervals for our range. The first interval is from -infinity up to -2, and we do include -2 because that does look like it's included. Union, well, the next interval starts at 2 and then goes upward to +infinity and forever and ever and ever. So the range, we actually need two intervals to describe that range, whereas the domain, we're defined for everything, so we just need just the one big major interval. For the next graph, recall earlier in the earlier video, we noticed that the graph seems to be ripping itself apart at 1. So we're defined to the left of it, right? I see values being generated, and we're defined to the right of it. So 1 is actually not included in the domain, but everything to its right is generating values, and everything to its left is generating values. So the domain would have to be two sets, from -infinity to 1, union from 1 to infinity. And then the range, even though there's a break in the action, right, we starting at 0, it looks like we have 0 coming out a couple of times. Right? Anything above 0 seems to be generated. Anything below 0 seems to be generated. Right? There are values of y associated with all parts of the y-axis. So this is a very strong function in terms of its range. It's defined for all values of y. Right? It's very, very strong. And then last but not least, how do we handle this crazy piecewise function? Well, again, domain, it looks like we're starting at -7 and including it. And if we go all the way, I know 2 seems to be a problem, but we are defined at 2, or excuse me, at 1, because when x equals 1, we have an output of -7. So despite the break there, this is part of the domain. And all these x values, all the way up to 6, right? Everybody between -7 and 6, all those x values are producing some y value. So that would be my domain. The range, however, we definitely have to break up into pieces. So starting at -7 and going all the way up to, looks like at +1. So -7 to 1 would be one aspect of our range, union. And then we pick up the story at 4. We don't include 4, but we go all the way up to what it looks like is 9. And so putting that in interval notation, we're talking about 4 to 9, where we don't include the 4, but we have the 9. So that is how we can find domain and range from a picture. Kind of matches a little bit of what we did in some earlier things. But so far, again, gathering information from a graph, being able to tell whether it's a function, being able to tell what the set of inputs is, the domain, and being able to define what the range is, the set of outputs. So much more to the story. We'll do that in some more videos coming soon.